Hey everyone, so this is going to be the video presentation lecture for Module 1 networking today. So I'm going to go ahead and share my screen. And if you want to follow along in your curriculum, you can. There's also a PowerPoint that you can use, but I'm going to have everything right in the video here for us to use. Okay, so we're going to start off just this week with Module 1. That's all we're going to work with. And a lot of this information we're going to come back to, but there is some fundamental stuff to get started. And like I said in my course overview video, don't take too much to heart. You don't have anything to pass in for points today. It's really just going through and acclimating yourself with the learning management system, or LMS. So over here on the left, you can see that we are in networking today, module 1, and we're going to go through all the way down to the practice and a little quiz, and those you can do on your own. And I'll introduce that to you as part of the course. So with no further ado, let's get going. Make sure this is decent size for you. So in this module, we're going to be introduced to a lot of vocabulary, and in your assignments, you're going to be introduced to the packet tracer software that I introduced in my course overview. So we're going to just talk about what networks are and some of the components, and the networking components will be reinforced through the packet tracer, their representation and what they are. We're going to talk about different kinds of networks and how we get connected to the internet. We're going to talk about what reliable networks are composed of and some trends that are happening today, as well as some basic security, and then what the IT field might look like. So one of the first things that you want to do is go ahead and download and install Packet Tracer. And Packet Tracer is a really robust simulation tool. Professionals use this to actually plan out and test networks, create prototypes. There's so many things you can do with it. And in my course overview, I introduced you to the little self-paced Skills for All class you're going to take. And there were a couple of other more advanced classes there as well. If you would like to take those, feel free. Very soon, you're going to be very familiar with this program and be using it quite easily. Okay, so here's a video here on how to install it, but just, to follow up what we did before, we're going to go to the resources tab. So in your class, under preparation for the course, there is a resources tab, and you can go to the download page of Packet Tracer and then download and install it. But you can watch this video. And then how to get started in Packet Tracer, that's a little class I'm asking you to take. It takes about 2 hours, but it may not take you that long. And then making sure that you learn how to save your completed packet tracers so that you have the points. And then again, there's a video here that does a quick overview, but you should do the course as well. And then there is what's called a logical and physical mode explanation. I did not walk through this one. I do want to show you it's a different little setup than the packet tracer that you're going to see, I believe. I'm just waiting for it to start. Nope, it's not. Doesn't look like it's going to be different. I have to wait for the file to open. So this one actually asks you to do a lot of things and says, don't worry, that you don't have to know what you're doing. You do not have to do this packet tracer. I don't believe I have assigned it, but if you want to, please go ahead. Just follow and it tells you exactly what to do. But I felt that that was a little too I felt that it was a little too complex. Let me just get a new window here because by accident I logged out of my class. It happens. Okay, let's try this again. So there's a cute little video here. I like this quite a bit on networks and how they are involved in our lives and all the things that they do and all the things that Cisco chooses to do. It's a great little advertisement for Cisco. Just to talk about Cisco, Cisco is a manufacturer of networking devices. They make switches and routers, and they make wireless and telecom solutions. They have security obviously devices, but they have uh, portals and things like Cisco Talos that talk that deal with cybersecurity and things like that. So they really are a force. They are not the only vendor. Steve Frechette will tell you that we want to keep everything in mind and be vendor neutral. I like Cisco products. I use them in my network as an IT director. That's I'm not averse to other products like you know uh, HP, for instance, makes network devices. I just happen to um, use Cisco devices. They're very common. They have excellent certification programs as well. And everything that you learn here with Cisco products, you can apply to other networking devices. What we're going to learn in this class is vendor neutral. It's standards in the networking industry. We just happen to use Cisco devices to practice some of the practical applications of those standards. Okay, so I want to make that clear. This is a great little video to watch. I think you'll enjoy it. And so what are we talking about? What makes up a network? And there's basically end devices or hosts. So this is kind of jumping the gun a little bit, but the word host in the IT world means that there's an address placed on this host. For instance, your cell phone would be a host because it has an IP address. Your computer, your laptop gets an IP address from your internet service provider. Any device that has an address that allows it to participate on the network is a host. Hosts are end devices. So you can see what I mean by end device, it's where the cable ends. We're going to talk about that in one of the packet tracer. So a server is a host, a client is a host, a printer, a cell phone, a regular IP phone. Your TV is a host. It has an IP address if you're allowed to stream video on your wireless network. So anything that really connects to the network. And what kind of things do hosts do? Well, some of the common ones are email, web, and file. So email is obviously being able to receive your email, and you can get those from a server, and then accessing web pages through your browser, and then creating and storing files. And with the network comes in with the files is you're not going to store your file necessarily to your local computer, but you would save it somewhere else. So when, for instance, let's say you work on a packet tracer or create notes or a Word doc, and you want to save it up to your OneDrive, right? That Bristol Community College gives to you. That would be outside of your computer, and therefore you would need a network connection to connect to your OneDrive. Dropbox would be the same thing, Google Drive, same thing. So when you leave your computer where you're creating the data, in order to save it in a different location, whether it's on the internet or on another device in your network, like a file server, that requires networking. So one type of network is called a peer-to-peer, and this is where the hosts, all the hosts or all the end devices have equal status. So if one host has resources like it wants to share, in this case, it's a printer, they can share it with another device on the network. I'm not going to go too deep into this, but suffice it to say, every device has to be individually installed and configured with user accounts, security, and applications. There's no central management or storage for a peer-to-peer network. All devices are considered equal. So they're super easy to set up because all of the components that you're going to need to do a peer-to-peer network are automatically built into any device that has a network card. I know I'm saying vocabulary here that you haven't seen, but we will talk about them in more depth. So they're very simple networks. You do not want these networks to get large. because I have to sit down at every device and configure it individually and put the users on every device and install the applications on every device, the more complex or the more devices there are, the harder it is to manage. It's a lower cost because I'm not using any expensive type of devices like a server or server operating systems, and having to invest in a lot of high-end resources. We'll talk about servers in a minute. And then it can be used for very simple tasks. Disadvantage, again, there's no central administration. That means there isn't a place where I can store all my applications. There isn't a central user database, which is really important in certain types of network, like the BCC school network or business networks. Peer-to-peer networks are really good for home networks or small office, home office networks. But once you start to get out of like a small office network, and I'm talking about 10 devices or less, having a server to run a database, to manage the internet, to manage the users, to be a repository for file storage so other people can share files and things like that, it becomes important. It's not as secure because we don't have higher end user management. Everything's managed at the local level, meaning the device itself. It's not scalable. That's what I was talking about earlier. When these networks get too large, they become too burdensome to manage. And then all devices act as both a client and a server, which can slow their performance. So what does that mean? I'm just going to tell you right now. A client is a device that asks for services. For instance, I'm going to open my Chrome browser and I want to ask to be connected to a web page somewhere so I can utilize that. I'm going to ask to receive my email and send my email. I'm going to ask for access to a file or an application. That's a client. A client is generally has user interaction. So a user is going to be using that client to do these requests. A server is a device that generally sits and its whole job is to serve. So if it's a server that manages user accounts, when someone logs in, their client asks to log into the network, the server responds and gives them a token to log into the network. If it's a print server, all the printers and their software is installed on the server, and a client will ask, I really want to print to this particular printer, and the server manages that process of translating whatever it is you're printing into printer language. Email server, a client would ask to please give me my email that I've received and send email I want to send. The server would manage the what we call post office boxes or your inbox for your email. It would also manage when to send or how to send email out. All of these things we're going to talk about in more detail. So when it says that an end device in a peer-to-peer network is both a client and a server, in this case, if this computer right here that I'm circling is going to share its printer out to another device on the network, it is acting as a server because it is serving print services to some other device. And so most of our hosts we consider end devices. So again, a host is any device that has an IP address that allows it to participate on the network. We'll talk about IP addresses later in like chapter 5, 11, and 12, I believe. So looking at this diagram, an end device is any device that is not connected to any other device. So this server, this PC, and these two users, and this phone right here, these are considered end devices. They're kind of, we call them little stub net, like a little stub, right? There's nowhere else for it to go. These devices in the middle are what we call connectivity devices or intermediary devices. They you do not sit at them and work. This is a switch, okay, kind of like your access point or your switch at home that connects to your ISP. And this is a router, and routers route information across. It's how we get the data from one end to another. The switch allows end devices to access the network. So this gives them a central place to all connect. And then the router gets the messages from one end to another. So more end devices over here. This is a server. This is a PC, two users, and another phone. So here are some of the intermediary devices I just mentioned. A wireless router that you use at home is considered an intermediary device. If you use what looks like, some people call it a modem, and it's really not a modem technically. It could be if you have, for instance, Xfinity, but not Fios, but like cable, ISP, you would use a modem. It's a modulator, demodulator, modem, modulator, demodulator. That changes your signals from analog to digital and digital to analog. Computers and computing devices use digital signals, and cable TV uses analog signals. We'll talk about that more, I believe, in chapter module 4. Then we have different things like different types of switches, which we'll discuss later. We have a firewall and we have a router. These are, again, connectivity devices. So what do? They regenerate and transmit communication signals. In other words, they get a package that comes in that you're trying to send from one place to another, and they get them and they forward them on. They maintain information about how to get from point A to point B. They let other devices know if there's failures. So again, up in this little situation, like these routers talk to each other, and if there's a single point of failure, like this cable right here goes down for some reason, this router and this router will talk and let the other routers know this path is not available right now. It could also discuss things like changes in speed, traffic conditions. It's kind of like having Google Map, right? They talk to each other and they update their pathways. They directed data along alternative paths if that's needed. They classify and direct messages according to priority. So if there's some type of priority like voice or data streaming, we consider that priority traffic over regular data like storing a file or browsing the internet. They'll manage that, and they can permit and deny the flow of data. So like a firewall can stop data from coming into a network or going out of a network. Okay, so first we have our end devices, then we have our intermediary devices that connect everything together, and then we have the media itself. And the media itself is what connects. So when I look up at this, all these little black lines are cables. But the media doesn't have to be a cable, like an Ethernet cable. It could be a wireless signal, like it could be a cell phone signal. It could be a wireless signal like you use with your laptop. It could be a hard wire. It could be a different types of hard wire. It could be fiber. It could be copper. It could be coax, right? And we're going to learn all about that in chapter 4. But here's some examples of different media type, right? And then things that we think about with media, I'm going to, again, address this in module 4, but what's a distance that a signal can travel, right? When would certain types of media be installed? Like if it's outside versus inside, or are you reconnecting buildings versus, or reconnecting rooms together versus computers right next to each other? Okay. We can skip that. For now, we're going to dig much, much deeper. So there is a check your understanding. Here's our first one. And basically, you can read the question, which of the following is the name for all computers connected to a network that participate in the network? And that's going to be our host, because anything that has an IP address is going to be a host. And IP addresses are required to connect to certain types of networks. When the data is encoded as pulses of light, what kind of media is that? And then you would just go back up in here, and they will tell you right here, different types of media and how they use it. In this one, data is encoded into pulses of light, and that would be fiber optic. I wouldn't expect you to know that now, so I'm going over it with you. And what two types of devices are intermediary or connectivity devices? Basically routers and switches. And then you would check it, okay? But if you got any of these wrong, for instance, and I reset, and I'm just gonna boom, boom, hosts and routers, and I check, it'll tell you which one you got wrong, okay? And it says you got 2 out of 3. In the green, it's good. You can try again, or you can click show me, and you can reset at any time. These are good practice to get you ready to make sure you understand the critical things in that section that they wanted to present to you. Okay, again, we talk about network representations, and we're going to address this in the packet tracer that I walk you through. but when we use packet tracer and in different things like Visio, or certain kinds of design software that help you put networks together, these devices have common representations. So this is just some examples, right, of what they are, and you're going to start. So here's an example of a wireless signal, and this is a LAN media or a cable, and this is wide network media. This is a different kind of cable. We will address these as we approach them, but for right now, they're just introducing that to you. Now, every networking device needs what's called a network interface card or a NIC. This is where you plug a cable into, or if you're going to have a wireless, you have a wireless network card in your laptop, for example. The NIC or the network card tells us what type of cable we're going to have to use, because it only takes a certain type of cable or medium, because if it's wireless, there's no place to plug a cable in. And it also has software on it that will tell us how to format the communication to send it out of our computer. We will get to that next week. So we have the physical port that a cable will get plugged into. And then we have interfaces as well on some intermediary devices, because certain devices like routers and switches also have ports on them. Again, we will get into this later, but just understand these terms. Okay, so now we're talking about topology diagrams. Topologies are charts, right? When you look at like Google Earth, you're looking at a topology. When you're looking at Google Maps, you're looking at a topology. Topologies are basically the layout of the environment. And we have two kinds of topologies in a network. We have a physical and a logical topology. A physical topology is just what it sounds like. It's literally where all the devices are physically located. It's attributes of the physical device itself. Okay, so is it an HP server? Does it have 3 network interface cards? Where is it located? What is the name of the device? Those types of things. Okay, so this is the physical device itself and where it's physically located. A logical topology talks more about the role of the device. Okay, so what's its IP address? What's its role? Because if you notice on this side right here, I have 3 servers. They're identical physical devices, but they each do different things. One's a web server, one's an email server, one's a file server. They could all have the same software or different software installed on them. So they could be the same exact physical device in a server room. They look identical, but they have different roles, and the roles make it logical. The other thing that makes a topology logical is grouping by role. So we might group computers, even though if they're physically separated across, say, the campus at BCC, we might take all the CIS computers in that department and group them in one department. So, for instance, the Computer Information System Department has virtual machines and software installed on the computers that CIS students get to use. That's a logical grouping. The business office could be a logical grouping. The faculty could be a logical grouping. Human resources could be a logical grouping. It doesn't mean that they are physically together in the same space, but we can create rules, boundaries, that allow or disallow certain types of traffic based on the groups. So faculty may have access to certain things in BCC's network that students don't have access to. Faculty is one group, students are another. And so we can manage the roles of those two groups logically, right? Not physically, not where they're located, because you could go and log in any computer anywhere on the Fall River, New Bedford, Taunton, Attleboro campus, for instance, and with your username and password, you would be part of the student group. I could log on any device anywhere and be part of the faculty group. So when it comes to logical topologies, the location physically doesn't matter. The physical location is used for network professionals to map out the network and to be able to recognize where they are and how they are connected to the physical infrastructure. The logical is used to manage the flow of data and to manage rules and services based on groups. Okay. If this doesn't make sense, we'll get into it more deeply, trust me. So here you can answer 4 questions. Which connection physically connects a device to a network? What connections are specialized ports? What type of topologies let you see which end devices are connected to which intermediary devices and the media, and which type of topology where you see the actual location and the type of cable that they're using. So you can do that on your own. So now we're going to talk about some common type of networks that we see. Networks come in all shapes and sizes. The smallest network would be 2 devices connected together with a cable or wireless. So an example of that could be your phone to a Bluetooth speaker. Bluetooth is a media, right? Bluetooth is a wireless connection. Your keyboard connected to your laptop, okay? Your laptop connected to an access point. These are all different types of networks, 2 devices connected together. The largest type of network we have is the internet, where we have millions, probably billions of devices all connected together in a big cloud. So they come in all shapes and sizes. So this example here, this is a home network. So we have different, I don't know if they're going to go through. Yeah, they're only going to talk about LANs. So a personal area network would be something, we call that a PAN, P-A-N, personal area network. That would be your Bluetooth headset to your laptop, your phone playing music on a Bluetooth speaker, your wireless keyboard and mouse connected to your device. These are personal area networks. They generally have a small physical location. They're limited in their distance, for instance, and we see those in home networks. This home network is just a small functional network. It has a computer, monitor, a couple of speakers, maybe a scanner and a printer. Then we have something that's one step up from that, and it would be a small office. And like I said before, this would probably no more than 10 computing devices or less. And they might be in a small office like a lawyer's office, like a small, like single or 2 lawyer partnership. Could be an accountant's office. It could be your dentist office, right? So, and these computers will be connected together in a little network so they can communicate with each other. They probably have a file server or some type of server that they can manage, and then they have access to the internet. But they're not going to require really big, expensive, robust devices. They may use an access point, right? They may have a small switch. Again, if you don't know what those devices do, you're going to learn it very quickly. Another type of network is medium to large networks. So these are more corporations. These would be something like Bristol Community College or the city of Fall River. They might have, I'm going to change that and give you another vocabulary, and that's called a MAN, M-A-N. We call those metropolitan area networks, and they tend to be maybe physically separate in buildings, but they're geographically kind of in the same area. So the city of Fall River would be an example. The BCC campus or campus system would be an example as well. All right. And they would require, BCC has more robust. They have servers, they have switches all over the place. They have cabling outdoors that connect the buildings. They probably use fiber for that. They have multiple servers that give multiple types of access, like you have access to Office 365, you have access to email for Bristol CCC. They may outsource some of their stuff to the internet as well, like, well, they don't use Gmail, but Gmail would be an example in a school. They have Microsoft services that allow you to log in through an outside vendor, but still using your BCC credentials. Okay, and the last kind is what we call the wide area, a worldwide network. And you can see this is geographically separate, and they could be global. So McDonald's could have a worldwide network. The United States CIA has a worldwide network, right? Even though they're based in the United States, they have offices at embassies all over the world. So that would be a geographically worldwide global network. Okay, so a local area network would be something. So really, to define a local area network, it's all the end devices before you leave your particular network for, and generally, we're going to talk about this later in chapter 8, module 8, but a router as an intermediary devices divide network. So this home office is a local area network. This central office is a local area network. Notice you have a router here that connects two different kinds of networks or allows you to go out to your internet service provider or ISP. The switches are part of a local area network. A router separates networks. Here's another router. And so everything inside the router is a local area network. Again, we're just introducing this now, and we will talk about this. It's in the packet tracer that I do with you. We just try and identify them and just take it for granted now. So they said LAN and WAN, but remember we had the PAN, personal area network, for just your computer, your device, Bluetooth devices. We had the MAN, a metropolitan area network, which is somewhere between a local area network and a wide area network. We have the LAN, which is a local area network, and we have the WAN, which is a wide area network. And they just talk about some different devices here. We can see this is a local area network. We have multiple devices all connected together. This is a server over here. And then the wide area network that we need the internet to connect to each other. Okay. In this case, branches could be like, this could be Fall River, this could be New Bedford. We could add another branch for Attleboro, another branch for Taunton, etc. And then the internet is what we call the network of networks. And these are a whole bunch of different kinds of networks all connected together around the globe. The difference between a wide area network, a corporate wide area network, and the internet is that a corporate wide area network manages the rules within its own realm, where the internet is a whole bunch of those realms all connected together. So it is the McDonald's of the world and the CIAs and all these networks that are autonomous, that all are interconnected. So you can see a little diagram here, and we have some more vocabulary for it. So we have the internet. We know the internet is encompassed by the world. That's global. It's the network of networks. It's a whole bunch of networks making up the internet. Out here in the internet, you are in a public space, okay? It's like being in a train station or an airport. You are in a public space. People can see what you're doing out there. People can access what you're doing out there. There is very little protection on the internet. There are ways you can protect your data, but the internet in and of itself doesn't provide those protections. You need to do that. An extranet is, well, let's go right to intranet. An intranet is inside the company. So an example of an intranet would be Access BCC, where you can go in and you can see your e-learning. You can see different resources that are available to you. You can see the school catalog. All of these things are available to you. Once you log in as a student, you have access to information that only a BCC student or employee might be able to see. We call that an intranet. An extranet is kind of a combo of both of those. Some things can be accessed from the internet. So for instance, I go to Amazon.com and I log in with my account. I have access to some things that Amazon allows me to see that are related to my account. I can purchase movies, for instance. I can buy items. But my information, like my credit card information and my username and password, are all managed on the inside. So people from the outside can't see it. So an extranet usually has a login. So I might go to Amazon and I might go shopping for Amazon, but I have to log in with an account to purchase the things and get credit for them. I could check out as a guest and never use a login, and that's a public space. Or I could log in with my account and have very specific settings for me that allow me here. If I were an Amazon employee, I could go into the internet as an employee and see even more information that's particular to that company, including the database that holds my credit card, for instance. So you can check your understanding on that. Okay. So how do we get on the internet? How do we access the internet and get outside? We have different types of connections, and some of these may sound familiar to you. We have DSL, which is digital subscriber line. We don't really see that anymore, but that used to be something that telephone companies provided, but now they do fiber. We have cable. When I said you might have cable TV, so digital subscriber line, sorry, would be through your phone company, and your cable would be through your cable company. Today, we have something called converged services, where a single company can offer all kinds of different kinds of connections. But it used to be a single kind for the phone and a single kind for the cable. And now phone companies and cable companies offer you both of those things. Then we have cellular data, so you're going to do that through your cellular provider. And then we have satellite services, so you might get some satellite services. If you live in the Midwest, for instance, they can't run cable, so they'll do satellite, like DirecTV, right? Or Dish. So you can get your TV, but sometimes you can get your phone and data through them as well. And then you have what's called a dial-up. So if any of you here are going to show your age like me, you would have a modem. Excuse me for 1 second. Okay, I'm sorry. I got interrupted, but I think I left off at dial-up telephone. I had a call that just came in. It was really important. I apologize. So here's the descriptions of each of these connections to an internet service provider. There are others beyond this. And I think we're going to get the chance in a later chapter to discuss that. Well, here's some more right here. Here are the ones I was thinking of. So those are for home networks, right? Like these are just basic connectivities. Think about who your ISP is, whether it's Verizon or Comcast or someone else. And then if you're going to be with business, you need a much more dedicated bandwidth, right, to manage multiple connections to the internet at the same time. And today that includes things like streaming. We're talking about our phones are on the internet now, not just cell phones, but the actual phones in an office. Those are digital phones now. They're not the dial-up or push button phones. They actually have networking capabilities and computer capabilities. So we have things called dedicated lease lines. This would come from the phone company, and what they do is they would give you a portion of the line, you would rent it, and you would be guaranteed bandwidth. And then Metro Ethernet is something like Metro Ethernet would be like a T1 or a T3 line. If you work for a business, you may not know about these, but basically you're going to call your internet service provider or another provider, and you're going to get dedicated bandwidth over fiber on the telephone poles or underground. And they're going to be speeds in the gigabits. I know we haven't done speed yet. When we talk about cabling, we will. And then you have a business DSL and or a satellite. So basically, suffice it to say that these types of connectivities for businesses are much more robust. They have a lot more bandwidth. They're much more reliable. Okay, so your home network is not going to be as robust or have the same speed as a business network. Okay, and so here are the descriptions of those. You do not need to memorize these. Okay, you might get some questions asked about them, but if you were to want to go for your Network Plus, this is stuff that you would need to dig deeper on. Okay, so converging networks, we already talked about this. Like when I said that in the past, it used to be a phone company that gave you your phone, your cable company that gave you your cable. Now we have something called a converged network where providers can offer different things. They can give you your TV, your internet, and your telephone all with one bill. right? And some of you may participate in that now. You have something over here, this rule agreement standard. We call this an SLA, or service level agreement. That's a contract that you have with your internet service provider, Verizon, Comcast, whoever it might be, Dish, and what services you're going to get for the amount of money that you're going to get. Okay, so what types of devices? Here they showed that they used to be separate, but now they're converged, and one provider gives you everything that you need for a cost. So this packet tracer network representation, I feel like that might be the one that we're doing, but it looks like a different number. So how do we make networks reliable? You're going to learn this as you go through your journey with Bristol Community College, but basically when we set networks up, we call that architecture, and we configure the architecture to make sure that if there's a single point of failure, like a server goes down or a cable goes down, or a business link goes down, that we have backups, right? So we call those backups fault tolerance. That's if there's a fault, we can tolerate it. And scalability is the ability to grow as a network. Remember when I said a peer-to-peer network really was limited to like 10 computers in the old days? Again, I'm aging myself. It used to be 15 computers. I don't think today you could take more than 10, just because of all the different applications that we have now. But scalability is the ability to grow as needed very quickly. Quality of service, that's the priority we talked about, having voice and video on your network. So whether you have internet phones, cell phones, or you need to stream data, or you need to do a lot of Zooms, you need to teleconference with different places, do speeches, anything that it might be. Quality of service prioritizes that data over different kinds of data. And then obviously security, which securing our networks is critical today. So this is things that we're going to create. So this just talks about fault tolerance. And this graphic just shows you if something goes down, we have another way to get the data. So you're driving to work or to school or wherever you're going to go, and a tree comes down on the road. You're not stuck there. You have another way to get to where you need to go because we have a road system. Networks are very much like that. Networks in the world are very similar to our transportation system via roads in the world. And we'll talk about that, and I'll allude to that too. Scalability, again, the ability to add devices, intermediary devices, end devices to your network. As the company grows, you're able to add users and add functionality because you have the equipment that can also grow, whether you're adding in another interface, you're adding in more memory, whatever, the device is not stagnant. You can actually upgrade the parts to make it do more. Quality of service, I already told you, it's the ability to do streaming, voice and video. So here's an example of IP phones, where your streaming video and your voice data is going to take precedence over other kinds of static data. And when we talk later in this course, we're going to talk about that type of data and how it gets from one end to another. And then network security to make sure everything is secure. Your passwords are secure, your applications are secure, user data, high priority, secure, right? Like if I'm going to give my credit card to somebody online, I want to make sure that they have security protocols in place to protect my data. We have security breaches every single day, and cybersecurity is one of the fastest growing fields in IT. And it's critical to make sure not only like user data, but health data and data itself, like big data, just if all kinds of data is secure and protected, as well as access to your network. So this is right down here, we talk about confidentiality, integrity, and availability. We call that the CIA triad or triad. It's CIA. Confidentiality means that we're going to keep data confidential. The only people that are allowed to see it can see it and have access to it. Integrity means that from one end to the other, the data stays intact, meaning there isn't someone in the middle that intercepts the data, changes the data, and then delivers it in a different state. That's called integrity. So we use something in cybersecurity. If you haven't started to take a class yet or you haven't taken a class, integrity, we use something called hash algorithms. So there's a code that's attached to a file. And if the file changes just one iota, one letter, right? One space, one bit, the hash ends up being different on the other end. So this just makes sure that nothing's been changed in a file. So where's that important? In your health data, in government documents, in critical applications. Like I'm an engineer for an automotive industry, and I just developed a brand new engine that can run on air, right? I want to make sure that none of that data has been intercepted and changed. And availability means you're up and available. We use what's called the 5 nines, 99.999% of the time. We want our data to be available when it's supposed to be. If you're flying on a plane and the traffic control system goes down, that's not a good thing. That means planes don't know who's controlling the airspace. So that information has to be available. When you need to get to school and you want to be able to log into BCC, you want it available. You don't want the servers down. You don't want to be told that you can't get into your account because their servers are down or the internet access is down. We want to make sure that the people who need to get to the data can get to the data. Okay, that's what we mean about reliable networks. Okay, we're coming to the end of this module, and I know there's a lot. This is very introductory. They're just kind of throwing everything at us. But where's our network? Where are our networks going? We have all kinds of things that we have to think about in IT. So some of the trends, and they'll go into these in more detail, are bring your own device. Can I bring my phone and can I connect to their wireless network and just use my own device to do my work? A lot of you will be bringing your own laptops in, and you're allowed to connect to the Bristol Community College wireless network. Then how do they configure that? How do they make sure they're protecting their internal data while allowing you to access the network from the outside? Because frankly, I don't know what's on your laptop. I don't know if you've been compromised. I don't know if you're doing bad things that have a virus that can infect our network. So how do they manage that? There are many ways to do that. So I guess I'll go through them now, right? So BYOD means you can bring your own device, connect to a network, and use it. And so systems have to be in place. And as you go through, if you're studying cybersecurity or security in general, as you go through, you're going to learn about this much more. Online collaboration. This is a big thing ever since COVID, like everything, like I'm using Zoom right now. I taught online classes, but never with BCC, never to this level. So we're communicating, and I'm going to have office hours, but we're not going to necessarily meet in person. We're going to meet over Zoom, and we're going to talk things out if we need to. We can meet at the drop of a dime and see each other face to face. When my son went to Europe, in the past, I would have to have a phone call that was very expensive, but we were able to meet every weekend and have a FaceTime, with him while he was over in Europe, and he was young, and we were able to communicate as if we were sitting in the same room. This is huge. If you're really young, you may not see this as a big thing. Gaming started a lot of this trend, and COVID really pushed the stuff up into everyone's reality. So collaboration is now a critical source. It's not even telecom, collaboration. It's the ability to run a document that several people have access to and can edit simultaneously. It's the ability to run a live meeting and run a document. It's the ability to manage a database, and everyone can manage or sync their databases or their versions of things with everyone else, right? So it saves us from having multiple versions of things. We talked about video communication already, right? And how important that is. And then cloud computing. This is one of my favorites, but it's also one of the most unsecure landscapes that exist now. So cloud computing is the ability to basically not have to have services on site in your network. you can outsource them to the cloud. So for me as an IT director in my school, I outsource a lot of things that I don't manage. My student information system, we use a different company and we log into their stuff. We have our school portal. We have all our student information there. It's all stored in the cloud. Students can access it. We can access it from anywhere on the internet. And they manage it, right? So the other company manages it. And as IT director, I don't have to manage that. I don't have to manage the actual computers in my network, secure them, everything. However, big misnomer that cloud computing is secure. It's not. You have to look at your SLA or your service level agreement, and you have to find out if what services they provide and how they guarantee their security. And this is a big piece of if you decide to get certified in cybersecurity and Security Plus, you need to know these things. So what kind of, and this is a big, really big area of cybersecurity too. I used to say it was 3 things, now it's 5. It used to be websites, networking, and programming, right? Python or JavaScript or XML, those types of things. Now you have to add in cloud computing and artificial intelligence. And that it's like a 5-legged stool, right? It's not the 3-legged stool anymore. It's 5 because all of these are equal components in cybersecurity now, in network security now. And so they all deserve attention. So cloud computing is big because a lot of people are saying, I can't manage the website. I don't have that many employees on hand with the expertise that's needed. I would rather trust my ISP to manage my network security. I would rather trust Google to manage my collaboration or Microsoft to manage my collaboration through OneDrive and Office 365. These are all cloud-based options. But that doesn't mean that your network is protected, right? You have to put other things in place. So we have public, private, hybrid, and community clouds, right? A public cloud is anything that's free that we can use. Private cloud is a cloud that you might create. So I have a private cloud. So does Bristol Community College. So kind of thinking about the intranet, right? They can create a cloud situation where a lot of their services are available over the internet. You just have to log in to get them. Your Microsoft Office 365, your OneDrive, is an example. This portal right now that you're using is an example. This one's actually a good example of a hybrid cloud. We manage the account, we manage all the settings, we manage all the users, but they manage all the equipment and the content. And then a community cloud, where things have been customized, and actually Cisco, the LMS you're in, is probably more of a community cloud than a hybrid cloud. So what do we see happening in the home? We see all kinds of trends in the home. We have what's called the Internet of Things now, IoT, where so many things in the home are managed over the internet. Your security system, your heating system, your lights, your garage, access to your garage, your car may be connected to certain things. And all of this is generally managed with an app on your phone. Your cameras, your security cameras. People have ring bells, right? And they can be anywhere. And that ring bell will come up on their phone and they can see exactly what's happening at their house. So these are called smart homes, and they are built with Internet of Things. Okay, we're coming to the end of the chapter now. And so another new trend is what we call power line networking. And this is really kind of cool. This is where they combine your electrical lines in your house with data. And so you can actually plug something into your outlet and you can get access for a data that way. The closest I've ever come to using something like this is my power over Ethernet devices. So I have a lot of access points in my school that I manage. And running power to all of those access points is hard. That's kind of the opposite of what this is. But if I plug an Ethernet cable into my access point, that powers it up. kind of like a USB can get powered up with a laptop. In this case, you're actually using the power lines in a home to also provide data and using those existing lines to um, uh, help transfer the data or flow the data through the house. They're really kind of cool, but I haven't seen it in action. I'd love to. Wireless is really important in what we're going to be studying, but you have wireless internet service providers and broadband service. So this is just the ability to use cell towers, for instance, and those types of things. So smartphone devices, smartphones are computers, so we always consider those end devices. And there are other kinds as well that we're going to talk about in module 4. Okay, I'm not going to spend a lot of time on this because this is going to come up later. It's going to come in your cybersecurity uh, courses, but there's all kinds of different types of attacks on networks that we need to make sure of. My job in this class is to make sure you understand how networks work, how data flows, and how networks are integrated with different systems, operating systems, ISP, internet services, all the different kind of services that you use. My job is to give you the foundation here. So when we talk about security threats, you understand how networks work. And that's really foundational. I told you it's one of the 5 pillars. And then what steps you can take to mitigate security threats based on what they're trying to target. So I'm going to kind of skip this because I'm not going to talk about it now. We will talk about some of this stuff, but this is really cybersecurity. But just keeping up with having things integrated into your networks to allow for control, right? And monitoring and prevention. But we will talk about those mostly when we talk about what's called the transport layer and firewalls and those types of things. So you can read that on your own and go ahead and take it. All right, so our last section here. So yeah, so at the end of this course, you have an opportunity to get what's called the CCST. It's not listed here. It's a Cisco Certified Support Technician in Networking. It's a 40-question test. This class will prepare you for it. You will be well prepared. I've had a student in BCC pass it already. I have a couple of others that are studying. I can give you some information on that, but I'm not going to do that until closer to the end of the course. Okay. And then we can talk about that. But there are ways. Some people will say some people argue certification versus experience. I agree. In the end, experience is more valuable. But if you're entering a new field or a new branch of the field, for me, it would be artificial intelligence. I don't have a lot of experience in artificial intelligence. I have a lot of knowledge of it. I use it, but I outsource it. If I wanted to enter that field practically, specifically, I would study and get certified in it so that when I enter the field, I have some credentials that allow me to get the opportunity that I'm looking for to then gain that experience. So if you're new to the field, certifications can be very important. They show that you have done the work and understand the concepts and the standards, and you've been able to pass a standardized test that certifies you and gives you a badge that you have experience in networking or are certified in networking, certified in building a computer, certified in cybersecurity at different levels, certified in internet and how it connects, certified in switches and how they're configured. There's all kinds of them. And this is something I have access to and I do regularly, and I will talk to you later about that. We're not doing this lab. So we've come to the end of this module, and here is a nice summary of everything that we've talked about, how the networks affected our lives, the different components, how are they represented, what are the different kinds of networks, the PAN, the LAN, the MAN, the WAN, right? How do we connect to the internet itself? What do we mean by reliable networks with fault tolerance, quality of service, scalability, those types of things? What are some of the trends that we're seeing in networks? What are the new landscapes that we're seeing, like bring your own device and collaboration and video conferencing and those types of things? And then how do we approach our knowledge of networking to security? How do we bring that knowledge to security? And we will address that later in the course. And lastly, how do we become an IT professional? What does that mean? Basically, what it means is you're going to finish a program at Bristol Community College. You're going to take seriously all the classes. If they're Python, take it seriously. Windows Server Administration, Linux administration, cybersecurity is huge on Linux. Basic networking, advanced networking, and cybersecurity, and advanced cybersecurity. These are all foundations, right? You get an opportunity to dig into cloud computing, which is still fairly new, virtualization and artificial intelligence. That's just going to add to your resume. So now there is this module quiz here that you can go through, just like the other check your understands. It's longer now, 15 questions, because it covers the whole module. So you can work on that, and that'll prepare you for the exam next week as well. And that is everything that's in Module 1 networking today. And that's like, I feel like I gave you everything in the kitchen sink, right? And it's a lot. But trust me, next week we're going to talk about standards in networking. It's going to be over your head a little bit. I'm going to ask you to be patient with me. I'm going to ask you some very simple regurgitation, some very simple demonstration of understanding. We are not going to dig deep in it. I'm going to introduce you to some new tools, and we're going to start there. And you're going to just show me like, okay, I'm accepting this. I'm absorbing it. I'm accepting it. I hear you. I'm recognizing these terms, but I'm not going to worry about having to know them fully, because you aren't, not yet. But I promise by the end of the course you will, because we're going to have a lot of repetition. Remember the onion, right? The onion. It's round. There's no beginning. There's no end, but there's a lot of layers to it. So if we're talking about, networking standards, about cabling, for instance, that's going to be, I'm going to tell you what to think, what to expect, like I did today. This is media, right? But then we're going to go deeper and deeper. We're going to go deeper into fiber. We're going to go deeper into copper. We're going to go deeper into coax, until you feel more comfortable with those type of standards. So I really, really want to encourage you to be patient, give yourself some grace. I'm giving you grace. We have nothing that's graded this week, but it's critical that you watch these videos, and it's critical that you spend the time learning about Packet Tracer. It's critical that you do the walkthrough in the Packet Tracer network representation with me that I put in your classroom, and you're going to be fine. I promise you. Okay. We'll see you next week.